Hey guys, welcome back to the DAHKTUBE. And before we get started, don't forget to like, share, comment, and subscribe. If you haven't watched the previous videos on integration, I'd advise you to go and watch those before you start here. So you can pause this, go and come back. So today we'll be doing integration theorem. So the first theorem is constant multiple theorem. So for example, let's say we have the integral of k f of x dx, where k is considered the constant. So what we normally do, because we're integrating with respect to x, we put the constant on the outside of the integral sign. So we'd have this here. For example, let's say we have the integral of 4x to the third dx. So because 4 itself does not have any x term, we put the 4 on the outside of the integral sign, and then we integrate as usual. So we'd have 4 times x to the 1/3 plus 1 divided by the new power, which is a third plus 1 plus c. So that would be 4 times x to the 4/3 divided by 4/3. So now we'd have 4 times 3/4, because you'd have to flip this, x to the 4/3 plus c. So the 4s would cancel here. You'd have 3x 4/3 plus c. Next example, let's say we have integral of 3x over root x dx. So here, the 3 would be the constant, so I can put that on the outside. So we'd have 3 integral x, and the root sign is the same thing as saying x to the half. So now what we'd have to do first is we'd have to carry this in the denominator to the top, and it becomes negative half. So it would be x times x to the minus a half. So now, because we're multiplying the same bases, we add the powers. So it'd be integral x to the 1 plus negative a half. So that would be 3 to the half. So that would be 3 times the integral x to the half dx. So now we start the integration process. So we have 3 times x to the half. So we add in 1, and then we're dividing by the new power, which is half plus 1. And then that's plus c. So that would be 3 bracket x to the 3/2 divided by 3/2 plus c. So that'd be 3 times 2/3 x to the 3/2 plus c. Because again, this is flipping. So then the 3's would cancel. So we'd have 2x to the 3/2 plus c. All right, so now we're going to be doing sum and difference theorem. So for example, if we have the integral of f of x plus g of x dx, the integral sign is distributed for all terms. So we have the integral f of x dx plus integral g of x dx. And the same thing applies for if you're subtracting. So we'd have integral f of x dx minus integral g of x dx. Okay, so for example, let's say we have the integral. That means the integral sign goes for the 6x squared dx plus integral 2x dx plus integral 1 dx. So we'd have, so if we integrate 6x squared, that would be 6x, we add 1 to the power, and then divide by the new power, plus, then we add 2x, so we add 1 to the power, so that's 1 plus 1, 2, divide by the new power. Now for the number 1, be reminded that 1 is the same thing as saying x to the 0, so anything raised to the power of 0 is 1 itself. So anytime you see a constant term, that means, for example, if you see 2, it will be 2x to the 0, which is saying 2 times 1. So you'll always add 1 to the new power, so it becomes x to the 1. Now we'd have plus x, which is x to the 1. And then we add the constant term c. So now we can simplify. So 3 into 3 that, 3 into that 2, 2 into 2 1, 2 into 2 1. So we have 2x cubed plus x squared plus x plus c, and that would be your answer. Again, let's try another example. Let's say we have the integral of 5x cubed minus 3x squared minus 2x dx. So we'd have the integral 5x cubed minus integral 3x squared minus integral 2x dx. So again, we add 1 to the new power, so it will be 5x to the 4 divided by the new power minus 3x squared plus 1, that's cube, divided by the new power, minus 2x, add 1 to the power, squared, divided by 2, and then we add the constant term c. So 5 and 4 cannot cancel, so that will be 5 over 4, x to the 4, minus 3's cancel here, so that will be x cubed, 2's will cancel here, that would be x squared, plus c. So now, last example, integral 8x minus 3x squared over root x dx. So if you recall from, let's say we want to add a half plus a quarter, we would know that you'd have to find the LCM, which would be 4. So 2 into 4, 2, 2 ones 2, plus 4 into 4, 1, 1, 1, 1, right? So that's basically saying 2 over the denominator plus 1 over the denominator. So 2 cancel this, so you get back the half plus the quarter. So it's the same thing here, where this is the denominator, or the LCM. So that means you'd have the integral 8x over root x minus 3x squared over root x. Right? So now we give each their own integral. So we know that the root sign is the same thing as saying to the half power. Minus integral 3x squared, x to the half. And again, because the x term is in the denominator, we'd have to take it up. So that'll be the integral of 8x times x to the minus half minus integral 3x squared times x to the minus half dx. Again, when we're multiplying the same bases, we add the powers. So it'll be integral 8x. So 1 minus a half, that would be a half. And then 2 minus a half, that would be 3 over 2. So it'll be the integral 3x 3 over 2 dx. So now we can actually integrate from here. So then, again, we know that we should add 1 to the power. So it would be 8x half plus 1, that is 3 over 2. And then we divide by the new power minus 3 to the 3 over 2 plus 1, that's 5 over 2. And then we divide by the new power and we add the constant term c. So it will be 2 over 3 times 8x 3 over 2 minus 3 minus 2 over 5 times 3 to the 5 2 plus c. So 2 times 8, that's 16. So that's 16 over 3 x to the 3 over 2 minus 236 over 5. Oh, I forgot the x here. X 5 over 2 plus c. And that would be a final answer. All right, guys, so that's it for part 1 of the integration theorems. We're going to be doing when we have product and quotient of integrals. So thank you guys for staying tuned, and I'll see you guys next time on the DAHKTUBE.